Kia ora Year 11 and 12. Here's the next revision video looking at another AS question. This one's also from the October-November 2015 paper, and it's got some differentiation, some integration, and a little bit of coordinate geometry. It's quite a lot like question 10, which I did yesterday. Okay, so let's have a first look at the question. Always worth reading right through it before you get going. So we've got a curve that goes through a point, and we're given the derivative of that curve. And we're told that there's a point moving along the curve in such a way that the x-coordinate of P is increasing at a constant rate of 3 units per minute. So we might just jot down as we go that means dx by dt is equal to 3. So we can think of some curve. This is y equals blah, blah, blah. And we've got a point P that is moving, making its way along the curve like that. Okay, and we've got a point on that curve, which is point A at x equals 6 and y equals 4. Okay, let's keep reading. Find the rate at which the coordinate of P is, the y coordinate of P is increasing when P is at A. So what we're being asked to find here is dy by dt. And as soon as we see that, and this, we should be thinking about the chain rule. Okay. Next, we're asked to find the equation of the curve. So the curve is coming from, let's just get rid of all of that. The curve is going to come from this up here, dy by dx. We're going to integrate that and use this information to help. And then the last question is looking at the tangent to the curve at A crosses the x-axis somewhere, and the normal to the curve at A crosses the x-axis at C. So in this question, we're going to find the equation of the tangent and the equation of the normal, and it's all being done at point A. So there's nothing in here that is really conceptually difficult. There's just a little bit of making sure you don't make silly mistakes as usual. So let's get started. Well, we've got dy by dx is equal to dy by dt times dt by dx by the chain rule. Now we need to find dy by dt in here, but we know dx by dt is equal to 3. Now that means that dt by dx is equal to 1/3. Okay, so we can treat these a bit like we treat fractions. So that's good. And now we can find this one here. So we're going to get this one, and then solve for what we're after. So let's, we've got dy by dx already. We don't have to find it. Okay, so in general, we've got 1 plus 2 on root x is equal to dy by dt times 1/3. So 3 times 1 plus 2 on root x is equal to dy by dt. And we're asked to figure that out at point A, which is 4, 6. So we're going to substitute in 4, and we get 3 times 1 plus 2 over the square root of 4 is equal to dy by dt. So 3 times 1 plus 2 over 2, which gives me 1, is what we're looking for. So dy by dt is equal to 6. Right, so that's the first 3 marks done. Now we have to find the equation of the curve, and this is just a straightforward integration question. So we're starting with dy by dx is equal to 1 plus 2x to the power of negative 1/2, and we know that 4, 6 is on the curve. So y is the integral of this, which equals x plus something times x to the power of 1/2. So to make this equal 2, I need to have 2 times the reciprocal of this here, which is going to give me 4, plus c. Substituting in this point gives me 6 equals 4 plus 4 root 4 plus c. 6 is equal to 4 plus 8 plus c. So c is equal to negative 6, and the curve is equal to y equals x plus 4 root x minus 6. So there we go, that's the second part done. Right, now on to the last part where we just have to be a little bit careful not to make silly mistakes. So let's look at what we've found so far. Well, we've got dy by dx, and in this question we're looking for the tangent to the curve at A. So to do the tangent to the curve and the normal to the curve, we're going to use the following equation. Well, we don't have to use this one, but I'm going to use this one here. The other one we could use is y equals mx plus c. But in here, to find the tangent at A, well, A is 4, 6. So that's going to give me this point, and m is the gradient. And we know dy by dx at x equals 4. We've already figured that out, right? It's 1 plus 2 over root 4, which is 1 plus 1 is 2 from above. So m is equal to 2. And for the normal, m is equal to negative 1/2. So we can quickly work out the two equations. We get y minus 6 is equal to 2 times x minus 4. Y is equal to 2x minus 8 plus 6 gives me minus 2. Over here, we get, well, let's do it using the same form. So y minus 6 is equal to negative 1/2 x minus 4. Y minus 6 is negative 1/2 x plus, what do we got here? Plus 2. So y equals negative 1/2 x plus 8. Okay, so we can think about drawing those lines now very, very badly because I'm in a hurry. Suppose this point here is 4 and 6. So where does this cut the x-axis? Let's go back to the question and see what we're trying to do. Right, we want to see where does the tangent cross the x-axis at B, right? And where does the normal cross the x-axis at C? So we've got these two very simple linear equations. We need to now find the x-intercepts. So we do that by solving 0 equals 2x minus 2, 2 equals 2x, so x equals 1. So point B is 1, 0. And I think it's worth writing it out like that. So here's B and here's A. Now, what about the normal? Where does that hit? Well, we've got 0 equals negative 1/2 x plus 8. Half x equals 8. X equals 16. So point C is 16, 0. So here that is down here. And here's my very badly drawn triangle. Okay, now we know that this height is going to be 6 because A is 4, 6. So the area of the triangle, we don't even need a complicated formula. It's just going to be half the base times the height, which is 1/2 times 15 times 6, which gives me 45, and I don't know the units. So it's 45 units squared. So there you go. That's one of the bigger questions in that AS paper. So just make sure you've revised all of those little bits and pieces of content. Thanks for watching. I will probably try and do an AS question a day from here on in.